Hello and welcome to Human Anatomy Prep. I'm Ty Gardner and I'll be your instructor. In this lecture we'll be taking a look at the skeleton. This is one ugly mind map, but it should help us be organized. Let's start by defining the two divisions of the skeleton, the axial skeleton and appendicular skeleton. We'll look at subdivisions of each. Here are the pectoral, girdle, and upper limb of the appendicular skeleton. Then we'll briefly discuss the bones of each of these subdivisions. Axial comes from axis, meaning midline. The axial skeleton is the stuff in the middle. The axial skeleton includes the skull, vertebrae, and rib cage. Appendicular refers to our limbs or appendages. The appendicular skeleton is the stuff away from the midline. Let's take a quick look at the axial skeleton. We'll start with the skull, but we'll look in detail at the vertebrae. Cranial bones include the frontal, parietal, occipital, temporal, sphenoid, and ethmoid bones. Facial bones seen in this diagram include the mandible, maxilla, zygomatic, and nasal bones. Some facial bones are a little harder to find, like the vomer, palatine bone, lacrimal bone, and inferior nasal concha. The skull connects to the spine where the occipital condyles meet the atlas, the first cervical vertebra. We recognize 5 regions of the spine, starting superiorly: cervical, thoracic, lumbar, the sacrum, and the coccyx. Each region has a number of vertebrae: 7 cervical, 12 thoracic, matching the number of pairs of ribs, 5 lumbar, 5 sacral, fused into the sacrum, and usually 4 coccygeal, fused into the coccyx or tailbone. When looking from the side, we see that the spine contains curves associated with these regions. The primary curvatures, in the thoracic and sacral regions, match the direction of the fetal spine. The secondary curvatures, cervical and lumbar, form as a child learns to hold its head up or walk. There are a few basic landmarks shared by all unfused vertebrae, generally illustrated by a thoracic vertebra. We exclude the sacrum and coccyx from this, as the vertebrae in those are fused together. The vertebral body is the large, roundish area. Bodies are connected by intervertebral discs of fibrocartilage. Processes allow for attachment. The spinous process sticks out posteriorly. Transverse processes to the side. The rhomboid major and minor both attach at one end to spinous processes of cervical or thoracic vertebrae. The spinal cord is located in a vertebral foramen. Intervertebral foramina allow spinal nerves to exit the vertebral canal. Vertebrae get bigger as you go down the spine, but size is a poor way to identify vertebrae from different people. Cervical vertebrae can be identified by the presence of transverse foramina, passages for blood vessels. There are 2 special cervical vertebrae to check out. The atlas, C1, connects to the skull and lacks a body. The axis, C2, has the dens, a knob the atlas spins on to let you rotate your head, like shaking your head no. Thoracic vertebrae can be identified by their costal facets, attachment sites for ribs. Costal means of ribs. Lumbar vertebrae can be identified by the presence of superior articular facets that face medially. Those same facets face superiorly in cervical vertebrae and posteriorly in thoracic vertebrae. The thoracic cage consists of 12 pairs of ribs, costal cartilages, and the sternum. The sternum has 3 parts: the manubrium, the body, and the xiphoid process. These each attach to different things, so they are helpful landmarks for describing things like muscle attachment. Let's talk appendicular skeleton. We'll start with girdles. What is a girdle? Girdles are the bones that attach the limbs to the axial skeleton. In the pectoral girdle, the clavicle attaches to the manubrium, and the scapula connects to the spinous processes of cervical and thoracic vertebrae via muscles. The scapula has a landmark, the shoulder socket, called the glenoid cavity, where the humerus articulates. In the pelvic girdle, the os coxae, os means bone, coxae means of the hip, connects to the sacrum. The os coxae is formed by 3 bones: the ilium, the ischium, and the pubis. All 3 bones contribute to the acetabulum, or hip socket, where the os coxae articulates with the femur. The upper limb consists of the humerus, radius and ulna, carpals, metacarpals, and phalanges. The lower limb consists of the femur, patella, tibia and fibula, tarsals, metatarsals, and phalanges. So, the same pattern is seen in both. The difference is a sesamoid bone, the patella, in the lower limb. The patella glides on the patellar surface of the distal femur, protecting the tendon of the quadriceps muscles. The humerus and femur have rounded heads that form a ball and socket joint at the girdle, allowing rotation. The upper limb allows rotation at the elbow. We call this pronation and supination. In these movements, the radius rotates in the radial notch of the ulna, allowing the twisting of the hand. In the lower limb, the sturdy tibia transfers weight from the femur to the foot. The thin fibula does not. The wrist is composed of 8 carpal bones in 2 rows. I generally suggest using a mnemonic, a verbal learning device, to make it easier to learn them. Starting on the lateral side in the proximal row, closest to the wrist, sum, lovers, try, positions. Then from the lateral side in the distal row, that, they, can't, handle. Again, using their names: scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. The tarsus is composed of 7 tarsal bones, 3 proximal ones, and a distal row of 4 bones. I don't use a mnemonic for these, but you can find some online. The 2 big ones are easy. The talus articulates with the leg, and the calcaneus is our heel bone. The metacarpals, hand, and metatarsals, foot, are 5 long bones linking carpals or tarsals to the phalanges. In both cases, we number them 1 to 5, starting at the biggest digit, the thumb, pollex, or big toe, hallux. The digits, fingers and toes, are the same. Both are composed of phalanges. Singular equals phalanx. Because there are 3 phalanges in each digit, except digit number 1, the thumb or big toe, that have only 2. We need more than a number to name a phalanx, so we add a word for location: proximal, middle, or distal. Digit number 1 has only 2 phalanges, so we only use proximal or distal. A complete name would look like this: the proximal phalanx of digit number 5 of the left hand. I hope this has been helpful. Your next stop is the video on articulations.